Hello. Today I will be discussing on the topic of set theory. This is the in this lecture I try to make an introduction on the topic of set theory. Well, look, what is the set? Actually, the set is a collection of things, collection of objects, but it is a general form. Okay, but in mathematics, set is more than that. A set is a well-defined collection of distinct objects. Distinct objects should be there and it should be well defined. For example, for example, look, 2, 6, 4. It is 264. Here, this is a set. Okay, this is a set, and you can you can find these numbers are within a bracket, and this bracket, curl bracket, is used in case of set. To represent a set, this bracket should be used. Now, it is distinct object, it has distinct object, that is 2, 6, 4 are the distinct. Okay, and it is well defined. It is well defined. It is well defined in the sense that we take the mathematical numbers. We take the numbers. We take the numbers of set. Here is even numbers. 2, 6, 4. It is a set of even numbers. So in this way, we can say that these 2, 6, 4, 4, 2, 6, 4, 6, 2, within the bracket 6, 2, 4, or 6, 4, 2, all are the sets. The arrangement of the objects in the set does not matter. Arrangement of the set does not matter. Look, this is 2, 4, 6, and you can arrange it in this way. 4, 2, 6. You can arrange it 4, 6, 2. You can also arrange it 6, 4, 2. So there are a number of ways in which you can represent the distinct objects. So arrangement does not matter in set theory. Now, look, here we have A, B, C, D, and E. These 4, A, B, C, D, E, these 5 are sets. Which one is correct? If I ask you which one is correct, then on the basis of the definition, a set is a well-defined collection of distinct objects. You can find only C and D C and D are sets. A, B, and E also a set. E also a set, but it is represented in another way. So A, B are not sets because 1, 2, 3, 4, 5, 5, 6, 6 here, 5, 5, 6, 6 are repeated. Okay, number of times 5 are there, number of times 6 are there. So this is not a set in true sense. And you can find B is not a set because it is not well defined. Here is also alphabet, English alphabet, numerical numbers, and Roman numbers. So this is not a well defined set. But you can say that it is also a set because if we take the English number, the numerical number, and Roman number to make a set, then this is correct. But you have to look into a objective, into your objective, and on the basis of that, you should define the object. If you like to form an if you like to form a set of numerical number, then it would not be a set. If you like to form a set of alphabets, English alphabet, then it is not a set. And if you like to form the Roman numbers, set of Roman numbers, then it is also not a set. So in that way, A and B are not sets. C and D and E are sets. But C and D, the arrange is different. Here, arrangement is different. Okay, here arrangement is different. So this is the same set, C and D. Order does not matter here. And look, E is also a set because X here, X belongs to set. Z represents the number and X is less than 5, less than equal to 5 and greater than equal to 1. So it is a set of 1, 2, 3, 4, 5. And on the basis of the property, this set has been written. On the basis of property. Okay, you can write a set on the basis of property. So this is one type of example. On the basis of property, I have made this set. Now, some common symbols used in set theory. Okay, so look, this symbol. We should write the set within this bracket, curly bracket. Okay. An example, you can say that 1, 2, 3, 4 within the curly bracket is a set. This is a set. Okay. This is the symbol. A union B. This symbol represents union. A union B. So A union B, suppose we have two sets C and D, then C 1, 2, 3, 4 and 3, 4, 5, and if you like to make an union, then 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 3 and 4 are doubled here. So the union of C and D is this. Now this symbol The inverse of U is the intersection symbol. A intersection B. So here we have an example C and D. An intersection between C and D is 3 and 4. What is the intersection? The common part. The elements which belong to both A and B set, which belong to both C and D set in this example. So 3 and 4 belong to C as well as D sets. Now this symbol represents the subset symbol. Okay. This symbol represents the subset symbol. So this symbol is a subset symbol. So what is the subset? Every element of A is in B. Every element of A is in B. Okay. In this example, C and D, okay, 3 and 5, sorry, 3, 4 and 5, these three elements, 3, 4 and 5 is the subset of C. Okay, subset of C. Subset of C. Now, proper set. The proper set. This symbol represents the proper set. Every element of A is in B, but B has more elements. Okay. Every element of A is in B. Every element of A is in B. Look. But B has more elements. B has more elements. In this example, 3 and 5. These two elements, 3 and 5, this is a set. This set is a proper subset. So proper subset, every element of A is in B, but B has more elements. Three and 5 is here. So 3 and 5 is here. So B has more element. Now A and this symbol is represent not a subset. A is not a subset of B. A is not a subset of B. 1 and 6, this element is not a subset of C. Look, this element is not a subset of C, because 3, 1 and 6 is here. So not a subset. A is not a subset of B. Here, this set is not a subset of C. Okay. Now superset. A has same elements as B. A has same element as B or more. So superset, this symbol represents the superset. So 1, 2, 3 set is a superset of 1, 2, 3. So A has same elements. So this set has same element with B set, with B set. This is A set, this is B set. Now, this symbol represents the proper, this symbol represents the proper superset. Proper superset. A has B's element. A has B's elements and more. Look, it is A set and it is B set. So A has more. A has same elements as B has. 1, 2, 3 are the elements in B, and 1, 2, 3 also in the set A, but there is another element 4 which is not in B. So A is a proper set, proper superset of B. A not a superset. A not a superset of B. Look, A is not a superset of B when 1, 2, 6 are the element of A set and 1, 9 are the element of B set. So these are not a superset of. So A is not a superset of B. This symbol represents this. A to the power C. It means the complement. Complement. Elements not in A. When this symbol is there, then you can understand that elements not in A. Elements not in set A. So look, BC represents 1, 2, 6, 7, 1, 2, 6, 7. So 1, 2, 6, 7, 1, 2, 6, 7 is a set, which elements not in C or D. Its elements not in D. Look, 3, 4, 5. These are the elements of D set, and complement of D 1, 2, 6, 7. 1, 2, 6, 7. So complement of D is not a complement of D. Complement of complement of D represents elements not in A. These elements not in here. Now, A minus B difference. It represents the difference between the two sets in A but not in B. So 1, 2, 3, 4 and 3, 4. Here 1 and 2 do not belong to set B. 1 and 2 do not belong to set B. So A minus B is 1 and 2. A belongs to A. Element of A is in A. A belongs to A. Elements in A. 3 belongs to this set. This is a set, suppose 1, 2, 3, 4, 1, 2, 3, 4, set C, and 3 belongs to this set. So this symbol represents belong to. Now this represents does not belong. So look, 6 does not belong to C set. 1, 2, 3, 4 C set. 6 does not belong to. We represent this symbol to introduce this. Now empty set. Empty set. What is the empty set? The null set. 1, 2 is a set. 3, 4 is another set. Okay. So the intersection, if we take the intersection of these two sets, then we get no elements. So this is a null set. Now power set. Okay. all subsets of A, all subsets of A. This is this set. 1 is a subset, 2 is a subset, 1 comma 2 is a subset. Okay, and this is also a set, null set, one set with 1, with 2, 1, 2. This is also a set, and 3, 4, 5. So this is the power set. All subsets of A is the power set. Null set, one set, 2, 1, 2. These all are the subsets of set A. Now A equal to B, equality. Both sets have the same elements. 3, 4, 5, 5, 3, 4. Elements are same, but order is not is important in set theory. So these are A equal to B. If this A, this is B, then both are equal. A multiplied with B, this is Cartesian product. Cartesian product. Okay. Now, what is the Cartesian product? 1, 2 is the set multiplied with another set 3, 4. So 1, 3 set, 1, 4 another set, 2, 3 another set, 2, 4 another set. Okay. Now 3, 4. So this is the Cartesian product of these two sets. In this way, you can make the product. You can make the product, the Cartesian product. Now, this is A. Now this is A. Look, with mod sign. This is a cardinality, the number of elements of set A. Suppose 3, 4 with mod sign, it means equal to 2. Because the number of elements is represented by this mod sign. We have 2 elements, so number is 2. Now this symbol is such that represents the such that in greater than 0. So what should be the set? 1, 2, 3 dot 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 3, 4, 5, 6, 7, 8 dot 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 dot. So n is a n such that. Now this colon is also represents such that. So this is the same. Colon and this sign is the same. This represents for all, inverse A. For all x greater than 1. For all x greater than 1, comma, x square greater than x. This represents for all. This symbol represents there exists x such that x square greater than x. Therefore, you know it very well. Therefore, natural numbers. These are the natural numbers. These are the natural numbers. Now integers. Integers are -3, -2, -1, 0, 1, 2, 3. All are the integers. Now, what is the rational numbers? What is the rational numbers? What is the algebraic numbers? What are the real numbers, imaginary numbers, complex numbers? Look, one by one, I will discuss all this. At first, the rational number. Rational number 1.5. Example, 1.5 is a rational number because 1.5 equal to 3 by 2. 3 and 2 are both integers. Both integers. So 1.5 equal to 3 by 2 is a ratio. So it is a rational number. 1.5 is a rational number. Okay. It is a ratio, rational number is a ratio of two integers. Now, algebraic numbers. To be a algebraic, a number must be a root of non-zero polynomial equation with a rational coefficient. This is a non-zero polynomial equation. Okay, non-zero polynomial equation because 39 is here. So x square, x square here, rational coefficient 2, 5, these all are the coefficient, these are the rational. As we have mentioned that these are the integers, so rational numbers. So rational numbers. So to be an algebraic number, a number must be a root of non-zero polynomial equation. So polynomial, many terms should be there. Polynomial means many terms. Variables are there. X is the variable. Coefficients are there. So this is a polynomial. Non-zero because there is 39. So x is algebraic. X is the algebraic number because all conditions are met here. 3x square minus 5x plus 39 is a non-zero polynomial. A polynomial which is not just zero. X is a root, that is x gives the results of 0 for the function. X is a root. X is a root because here to be algebraic number must be a root. So x is a root. X gives the result of 0 of the function. The coefficient, the number 2, 5 as I mentioned, the 39 are the rational numbers. These are the coefficients are rational numbers. So the condition that a number must be a root of non-zero polynomial equation with rational coefficients are satisfied in this equation. So x is a algebraic number. Okay. Now real numbers. What are the real numbers? Real numbers are just numbers like 1, 12.38, minus 0.86, 3 by 4, pi, pi, 22 by 7, 198. So real numbers are just numbers like nearly any number you can think of is a real number. Any number you can think of. Imaginary numbers. So what are the imaginary numbers? An imaginary number when squared gives a negative result. What is the imaginary number? The number, if you make a square of that number, you get the negative. So that is called imaginary numbers. Look, in this example, imaginary numbers, I means root minus 1. I means root minus 1. If you take the square of this, then we get the negative value, that is minus 1. So imaginary numbers, 3i is a imaginary numbers. Complex numbers, what is the complex numbers? It is a mixture. Look, real number and imaginary numbers makes a complex numbers. 7 is a real number, 3i is a imaginary numbers as I mentioned. So this is a complex number. This is a complex number. So I hope in this lecture I try to clarify the fundamental introduction to the set theory, and I hope that you have enjoyed this. Thank you very much.